and who else?
Initial.
Yes, yes. Thank you. Okay. The first thing I want to do is go over the midterm exam. So I hope you have a copy near you. The first question is straightforward. So although many of you screwed it up because you didn't read the question properly, we have 100 hertz. Okay. So the minimum sampling then, the minimum sampling would be 200 hertz, but that's not the question asked. The question asks for the minimum sampling. The question says we're sampling at twice the minimum rate. At twice. So what is the sampling? Fs then be 2 times 200 or 400 hertz. Any questions about that? We don't always sample at the minimum value. Quite often we don't sample at the minimum value. In the real world, we quite often sample slightly above the minimum value. 2, there was a problem with the question. So here's the question. Here's the question I asked originally, and for some reason it got changed in the editing. So FM. So I have 3 frequencies, 100 hertz, 400 hertz. This is not the question I asked. This is the question I wanted to ask. 600 hertz. Okay, those are my 3 lowest frequencies. So this one's going to be FM. This one's going to be FS minus FM. And this is going to be FS plus FM. So clearly the sampling would be, the sampling with FM is 100. 100 hertz. FM is 100 hertz. And FS minus FM equals 400 hertz. So FS is equal to 400 plus FM, which would be 500 hertz.
Are you going over the midterm?
Yes, I am. I said that 5 minutes ago.
Sorry, I was, my Zoom was updating. I just come in.
Well, then you need to be quiet until it finishes updating.
All right.
Is it not clear I'm doing question 2 of the midterm?
It is, but I just wanted to ask just to be sure.
Mr. Johnson. Anyway, let's move on. Any questions about this?
You could double check your answer by putting in the stuff to get 600 by the FS and the FM.
There you could. 500 plus 100, 600. Okay. Almost all of you, except for one person, I think, got the second part of the question right. So once you got a FS from this first part of the question, okay, then the second part of the question is simply, so this is 2-1 if you like, it's 2-2. Okay, the cutoff frequency FC is FS over 2. So whatever you got for the first part of the question, just divide by 2, and I gave you the right answer. So in this case, this would be 250 hertz.
Man, you cost me getting a couple of points.
Excuse me?
I say I might have get them a couple of points.
The points don't matter because they weren't counted. You can't get points if they're not counted.
No, that's what I mean. And if it was counted, I might get it.
Yeah, but if your auntie had nuts, she would have been your uncle. What's my point here? You can't go by if in your life. You got to deal with what the facts are. Okay. Any questions about questions 1 and 2?
Oh, for number 1, you said F minimum was 200. How did you get that?
Because FM's 100. The minimum sampling frequency is twice the highest frequency in the input. Ms. Buchamp?
Yeah, I got it.
Oh, okay. Anybody else? Okay. Move on to number 3. So we have unipolar. Unipolar, at least one student forgot it was unipolar. Or either forgot or didn't know the significance of that statement. So that means the input goes between 0 and 10. That's what that means. So the range, this is the range, 0 to 10. So the range is 10. This quantization step is R divided by the 2 to the power number of bits. So 10 divided by 2 to the 4, 10 divided by 16. .65 volts. Yes, it is volts because the range is in volts. Any questions about that? Okay. 4. We have X of n equals 15. This delayed step function delayed by 3. So we want to plot that. So here's X of n, here's n, begin at 3. And some of you were making up your own notation, etc. Okay. And that's 15. Any questions about that? And then we have to define X of 1. X of 1 is 15, U of 1 minus 3. 15, U of negative 2. And U of negative 2 is 0. So it's 15 times 0. So X of 1 is 0. Any questions about that? And then X of 10. X of 10 is 15. U of 10 minus 3 equals 15. U of 7, but U of 7 is 1. 15 times 1 equals 15. Any question about number 4?
You're gonna just read the graph, right?
I guess so. If you went out to 10, if your graph went out to 10, you can read it. Next time I'll write calculate, and I'll stop you from reading the graph. Well, you can still read the graph for verification, but you'll have to do the actual algebra. Okay. Number 5. Number 5, we have a sequence for X. Okay, and we're told that this is for n equals 0. So this would be n equals 1, be n equals 2, and this would be n equals 3. So in terms of impulses, this is x of n 3 delta of n minus delta of n minus 1 plus 2 delta of n minus 2 plus 4 delta of n minus 3. Any questions about that? And while I say while I'm here on this question, it says write an equation. Write an equation. And what did some of you do? Some of you just wrote that as an answer. That's not an equation. An equation needs an equal sign. An equation has a left-hand side and a right-hand side. And there's an equal sign in between. That's what an equation is. Any questions about question 5? Okay. What's next? 6. We have x of n is 30 sine 4 pi over 7 times n. Clearly, the amplitude is clearly 30. Digital frequency is 4 pi rads, 4 pi over 7 rads. And then the period we calculate from 2 pi over omega, which is 2 pi over 4 pi over 7, okay, which is 14 pi over 4 pi, which is 7 over 2, it's n over m. This is the digital period. N equals digital period equals 7 samples. Any questions about that? I hear no questions. All right. So number 7. Draw the diagram. I sent you the diagram by email. So I'm not going to redraw that. 2. This is A0 equals 1. A1 equals 0. A2 equals 0.1. This here is A. This here is B1. B2 equals 0, and B3. And B0 is clearly 0. So A is going to be 10.1, and B is going to be 0.801.2. Any questions about that? Okay. And then the transfer function. This is y of z plus 0.1 z to the negative 2 y of z equals 0.8 z to the negative 1 x of z plus 1.2 z to the negative 3 x of 3. Okay. So this would be 1 plus z to the negative 2, 0.1 z to the negative 2 times y of z equals 0.8 z to the negative 1 plus 1.2 z to the negative 3 times x of z. So y of z over x of z, 0.8 z to the negative 1 plus 1.2 z to the negative 3 over 1 plus 0.1 z to the negative 2. Okay.
Times space e squared. For the
Excuse me?
Now your
Excuse
time.
me?
Now your time space e squared for the top and bottom.
Why you multiply by z squared?
If I remember correctly, so the denominator could have 1 in front. Something like that.
No. It should be multiplied by z cubed.
That's what I was supposed to ask you. I thought it's the denominator we used to look at, but we probably used to look at it.
No, you want to put it on the standard form, so you don't want any powers. You don't want any negative powers of z. You don't want any negative powers of z. So the highest, yeah, you don't want any negative powers of z.
All right.
So multiply top by z cubed. So this would be 0.8 z squared plus 1.2 over z cubed plus 0.1 z. And that's standard form right there.
All right, I got you.
Excuse me?
Nice, I got you. So you multiply
Oh,
with
yeah.
the highest delay.
And then, of course, the bottom factorizes by that. I didn't ask you to do that. So this is b8 z squared plus 1.2, and the bottom becomes z squared plus 0.1. But you don't have to do that bottom step. Any questions about that? Okay. 4. We have x of n equals delta of n plus 4 delta of n minus 1. And we have h of n equals delta of n minus 2. Okay. From this is a FIR filter. So just change h to y and delta to x. And there you have the difference equation. The difference equation. And then from the difference equation, we can get the output. This y of n is x. It's just x delayed by 2. Delta of n minus 2 plus 4 delta of n minus 3. And that's part 2. That's part 2. Or we could get, from here we know x of 0 is 1 and x of 1 is 4. Or we can get y of n equals convolution x of 0 times h of n plus x of 1 times h of n minus 1. So this here is 1 times h of n, delta of n minus 2, plus x of 1, 4 times h of n minus 2, n minus 1. So here's h of n, we just delay that by 1. Okay. Either way, you both get the same answer. Both ways gives you the same answer. You get the answer from the difference equation, or you get the answer from the convolution equation. Any questions about that?
What do you mean you get the answers from the different equation?
I just did that up here. Here's the difference equation. You agree that's the difference equation?
Yes, sir.
So what's this saying? It's saying the output is the input delayed by 2. Isn't that what that's saying?
Yeah.
So what's the input? There's the input delayed by 2. Delay this by 2 and you get this.
No, that's the easy way.
That's the easy way. That works in this case. That doesn't always work. I mean, you could always get the answer from the difference equation, but sometimes there's not always an equation for the output. You get a numerical value. All right. This is the convolutional equation. This is the one I expected you to use. Okay. And then finally, what's h of z? Here's h of n. H of z is just a z transform of h of n, which is the z transform of delta of n minus 2, which is simply z to the negative 2. Any questions about that? Okay, I did that in 30 minutes. I did it in 30 minutes while explaining it to you. Where's page 1? What did I do with page 1? Oh, there it is. Okay. All right. So now the semester is half gone, but the work is not half done. We have lots of work left. All right. So now we're going to speed things up on the second half. Okay. The first thing I want to do now what kind of function is this? What kind of function is this?
It's a quadratic.
It's not a quadratic. It's a quadratic divided by a quadratic. It's a quadratic divided by a quadratic. It's called a rational function. A rational function, as you should know from 320 or Math 167. Furthermore, this is called a proper rational function. A proper rational function. Why? Because the numerator order, and the order is the highest power, is not greater than the denominator order. But this is not a strictly proper rational function. For that, you need the order of the top. Let's say be less than the order of the bottom. This is strictly proper. Strictly proper. Rational function. Okay. Now, if we want to find the inverse z of this, we can't do it because that's not strictly proper. We have to make that into a strictly proper. And do you remember how we do that? From 320, do you remember how to do that? and I'd be shocked if you did. Why? Students don't retain knowledge because they cram it. We do long division. So z squared plus 0.1z plus 0.3 divided by z squared minus 0.5z plus 0.9. That goes into that one time. Okay. So z squared minus 0.5z plus 0.9. We subtract. We got what? 0.1 minus 0.5. That's 0.6. 0.6z. Okay. And we got 0.3 minus 0.9. That's negative 0.6. Okay. So indeed, this here is 1 with remainder 0.6z minus 0.6 divided by z squared minus 0.5z plus 0.9. Okay. So you see that rational function that is proper but not strictly proper is equal to 1 plus a strictly proper rational function. Let me let you get a try.
I can see the. I get a picture of that, please. I got it. Thank you.
So 6. I want you to try this one. This is a proper rational function, but it's not strictly proper because the numerator order is 1 and the denominator order is 1. So send me your answer. Send me your answer in chat. Boy, change that into the strictly proper. A constant plus a strictly proper. With Bootcamp, you need brackets. You need brackets to clearly tell me what you mean. This is why you got in trouble last night. You didn't have brackets where you needed them. No, you got too many brackets.
Stop that.
No, you do. You have to. You don't put more than you need. Oh, uh, Mr. Stewart did the same thing as you did, Mr. Buchap. You sure you're not communicating with them?
How I can communicate with them?
What do you mean? How you communicate with them? Right through chat.
And I texting you.
Yeah, but you can be texting them too.
I didn't even know that was possible.
Sure it is. Y'all can send chats to each other, and I wouldn't know.
Oh, I thought you mean I gotta chat to two y'all at the same time.
No, I didn't say that.
Oh, well, I was texting you. I can't text them at the same time.
Okay. All right. It's good to know you're not texting him, but it's just coincidental that he sent the same wrong answer. Well, no, it's not wrong. He had too many brackets. Okay. Anybody else want to try?
So the last one I said was correct?
Yes. Well, I assume it's correct. I haven't worked it out, but it's got the right form.
Dakar, you need me to change that answer?
Excuse me?
Do you need me to change that answer? You were saying there's too many brackets.
No,
okay.
No. All right, let's do it then. So we do long division. One goes here. The -1 goes here. And we subtract. We have 2 minus -1 gives us 3. Therefore, this here is 1 plus 3 over z minus 1. Okay. So this is the correct answer. You either write it that way, or if you want to write it in line, you have to write it as 1 plus 3 divided by open bracket z minus 1. If you just write 1 plus 3 divided by z minus 1, you know what this means? This means you're adding this to this, and then you're taking away this. That's what that means. But that's not what you're doing. You're adding this to 1. Okay. All right, I'm not doing any more examples on that. There are more questions in the book. You could test yourselves in the book. Okay. We looked at how we find Laplace transforms. We want to do the reverse today. The inverse Z transform. Okay. So if I give you x of z equals z over z minus 0.8, then you know right off the bat from the table, okay, if x of n is equal to 0.8 to the power of n u of n, if that's true, then x of z is z minus z over 0.8. So we just work backwards. So the inverse z of x of z, or the inverse z of z over z minus 0.8 will be 0.8 to the power of n u of n. So we use the table, so we have to know the table. So I assume that you learned the table because you could have been tested that on the midterm. And I imagine some of you were disappointed that you were not. Okay, let's do another one. Let's do this one.
I can get a quick shot of the last page. Sorry. All right, thank you.
Okay. If we go to the table, we'll see something of this form. In the table. And we know this is the Z transform of cosine omega n u of n. Okay. So we see that we check this. We see this is the right entry. We see that this is twice this, which corresponds to this being twice that. You see this one and that one is the same. So we know that this is a cosine wave. We know this is Z transform of cosine wave. Okay, and furthermore, we know that cosine omega equals 0.9. Okay, therefore, omega equals inverse cosine of 0.9. And inverse cosine of 0.9 is how much? .4510. Therefore, inverse Z of Z squared minus 0.9 Z over Z squared minus 1.8 Z plus 1 is equal to cosine omega 0.4510, okay, times n u of n. Any questions about that? Okay, try this one. Try that one. Let me answer in chat. All right, pay attention, folks, because I ain't got nobody sending me anything. Remember to use that formula. We need this number here to be half of this number. So the top, we modify, we take the 2 out. So z squared minus 0.45 z over z squared minus 0.9 z plus 1. Okay. And now what we have is 2 z squared minus cosine omega z over z squared minus 2 cosine omega z plus 1. So now cosine omega is 0.45. So omega now is inverse cosine of 45. And of course, you want your calculator on radians. So that's 1.104 radians. Okay. So then this here is the z transform of 2 cosine 1.104 and u of n. All right. This 2 corresponds to that 2. All right. So the inverse z then, the inverse c of 2 z squared minus 0.45 z over z squared minus 0.9 z plus 1. We could bring that 2 out. This is 2 inverse z of z squared minus 0.45 z over z squared minus 0.9 z plus 1, which is 2 cosine 1.104 and u of n. All right. So remember, we're finding inverse z transforms by using the table. All right. So when we look at that, we have to say to ourselves, that's almost a table entry. What do I have to do to this to make it a table entry? And clearly the answer is we have to bring up the 2. Any questions about that?
Hey, Dr. Kadri.
Yes.
We made, how did we made it 0.45 again? We had to make it half of the bottom.
Yes. In this example, that's not always going to be true. Just in this example, that's true. Any other questions? Okay. So this is something you're going to have to practice. Just like with Laplace transforms, you have to practice Laplace transforms. Let's do another example. Let's do, we have h of z for some system. We want the impulse response. This is a transfer function. So the impulse response is h of n, which is the inverse z of h of z. That's what impulse response means. Okay. So we want inverse z of z squared, z negative 2, sorry, 1 plus 0.25 z to negative 1. And we have, rewrite that. And we have multiply top and bottom by z to 1. This is not an entry. This is not an entry in the table. What do we do to that to make that entry in the table? What do we have to do to make this entry in the table? Half the bottom, Mr. Johnson? Why? What does that mean, half the bottom? This is not the same example as last time. You have to know the table. I guess you don't know the table. I guess none of you know the table. I told you to learn the table. You have to know the table for the midterm exam. So I assume that you know the table. But apparently if you knew it, you crammed it and you've forgotten it. What's in the table is z over z plus 0.25. This is the entry in the table. That's the entry in the table. But if we made that z, we got to make this z to the negative 2. So we haven't changed the top. Everybody see that? So what's the inverse z? What's the inverse z of this? Well, another way of asking the same thing, what time domain function gives this as a z transform?
That is in the beta U of n? No way.
Yes, it is. Yes, it is. This is negative 0.25 to the power of n u of n. Why? Because the entry in the table is beta to n u of n. The z of that is z over z minus beta. So clearly here, beta is negative 0.25. So this is the inverse z of this. What does the z to the negative 2 do? What does that do? What does the z to the negative 2, what does that do? In the z domain, when you multiply by z to the power of an integer, negative integer, what do you do in the time domain?
It's not a delay, no?
Yes, it is delay.
Delay by 2.
Delay by 2. So where you see n, put what? Where you see n, what do you put?
Put n minus 2.
Put n minus 2. Therefore, the inverse z of z to the negative 2, z over z plus 0.25 is equal to negative 0.25 n to the power of n minus 2 u of n minus 2. That's it there. That's what h of n is. This is what h of n is. Negative 0.25, the power of n minus 2, u of n minus 2. Any questions about that?
You could slide the paper to the left a little.
To the left?
That's all.
What's wrong with the positions in now?
No, I will make sure I get everything to the end on the last line. I see.
It looks fine. It looks fine on my screen.
Oh, I just wanted to make sure nothing got cut off. All right.
Again, what are we trying to accomplish? Mr. Johnson just wants to take one rule and apply it to every problem. In the first example we did, maybe that's the second example. We had to make the numerator half of the denominator. But that worked just so that we could get an entry in the table. In this example, we need an entry in the table. What did we have to do to get an entry in the table? Well, we had to put it in a standard form, okay? Here's the standard form part of it, okay? But we had to create a delay of 2, z to the negative 2 to do that. So we do whatever we have to do to get an entry that's in the table. And that's going to change from problem to problem. So one rule ain't going to solve all your problems. You're going to have to know the table. You're going to have to look at the function carefully. And you have to say to yourself, what do I have to do to this? What do I have to do to this to get an entry in the table? All right. By the way, this is exactly what we have to do with Laplace transforms. All right, let's try something else. S. Let's try this example. X of n equals U of n. And Y of n equals 0.89 to the power of n U of n. All right. Find the transfer function. Find the transfer function. What am I going to do?
Oh, would it be y of n over x of n?
Absolutely not. Boy, I tried to drill this principle in you. Go ahead.
You have to use the entry where it does z over z minus beta. You will get along.
Tell me what you're trying to do, Mr. Beauchamp. What are you trying to do? Mr. Beauchamp, I'm just asking you to tell me what you're trying to do without telling me what you're giving me the mechanics.
I know the mechanics of how to do it, but I get the answer, but I can't explain to you what I did.
Well, that's no good. Suppose I came in here and said that.
I have y of n, but I turn it into
You turn it to what?
I basically use a G transform that is equal to this y of n.
So let me put in English what you're saying. You found y of z.
Yeah.
You found y of z. And what did you find y of z to be?
The formula was z over z minus beta, so that's z over z minus 0.89.
Okay. You found y of z. What else did you find?
We could find x of z.
You can find x of z. What's x of z?
X of z, that's z over z minus 1.
Yeah, it's just a step. Yeah. Now, why did you find y of z and x of z?
Because the transfer function is y of z over x of z.
Yes. Yes. The person who said the transfer function was y of n over x of n should be shot. No, I don't mean that.
I meant the same thing.
Why? I drill this into you all in 320. Transfer functions are not defined in the time domain. Transfer functions are not defined in the time domain. Transfer functions are defined where? In the S domain or in the phasor domain. We call that the frequency domain, the Z domain. H is Y of Z over X of Z. That is not Y of N divided by X of N. If that was the same thing, why would we need Y of Z and X of Z? So the transfer function is Z over Z minus 0.89 divided by Z over Z minus 1. So clearly the Z's cancels. And we're left with Z minus 1 over Z minus 0.89. That's the transfer function. find the transfer function. 1, 2, find the impulse response. Are we going to find the impulse response? How are we going to find the impulse response? Just told you in the last example. In the last example, the impulse response is the inverse z of the transfer function. We just did that. We just did that. So we need to find the inverse z of z minus 1 over z minus 0.89. What's wrong with this? What's wrong with this? What's wrong with this function?
It's not in the table.
Say again?
It's not in the table.
Okay, it's not in the table. Well, what else is wrong with it?
Yeah, get rid of that one in the numerator. Hold on, let me see.
Well, that's true, but I'm not talking about this particular function. What's wrong with this particular function?
Well, it's proper.
It is not strictly proper.
Yeah, it's not sure you have to divide.
We have to do the long division. You have to do the long division. Why do you think I began with today's lesson with that? So z minus 1, z minus 0.89, that's 1, a z minus 0.89, that being negative 1 plus negative 1 plus 0.89.
Negative 0.11.
Negative 0.11. So this here is 1 minus 0.11 over 0.89. Okay. Is this an entry in the table? Is that an entry in the table?
Yes, sir.
Yes, it is. Is this an entry in the table?
Hold on now. Triangle z to the numerator.
So can we put a z in the numerator? If we put a z in the numerator, what must we do? What can we do if we put a z in the numerator?
You multiply top and bottom by z.
No. Well, yeah. That's the same thing as saying what? You put a z here, you have to put a z negative 1 here. Isn't it? What you just said is true. Okay, you multiply top and bottom. If you multiply the bottom by z, that's the same thing as multiplying the top by z to negative 1. Okay. Is this entry here in the table? Yes. Yes. So we're going to need the inverse z of 1 minus the inverse z of 0.11 z over z minus 0.89. Okay. And of course, that's the same thing as the inverse z of 1 minus inverse z of 0.11z over z minus 0.89. And what's the inverse z of 1?
Delta.
Delta of n.
Delta of n, sorry.
Delta of n. Okay?
Mm-hmm.
Minus, I'm going to bring the 0.11 out. 0.11 inverse z of z over z minus 0.89. I left off that sucker there. I forget to see the negative 1 here. Yeah. Go to the next page.
So you brought a negative 0.110.
Why?
I'm asking.
What do you think? Because is this entry on the table?
No.
Well, I'm getting rid of all the things that are not entries. So then we finally have h of n is delta of n minus 0.11 inverse z, z to negative 1, z over z minus 0.89. Okay. And we know the 0.11 here. And we know this. What's that? What's the inverse z of that?
That's 0.9 to the power n minus 1 times w of n, no?
0.89 to the power of what?
N minus 1.
N minus 1. U of n minus 1. Don't forget the u of n minus 1.
Oh, yeah.
Because that's going to change the answer. Right. So this is what's in the table. That would give you n here and n here. And this says shifted by 1. So you see why I brought the 0.11 out? Any questions about this? And again, this is something you're going to have to practice. If you don't practice this, when I give you a z transform and say, "Fuck, give me the inverse," you ain't gonna know what to do. Look at chapter 6. Look at the question section. There's a whole lot of questions there about finding inverse z transforms, and each one of those questions are testing: do you know a principle that you need to get the inverse z transform? Okay. Let's see what else I got for today. Okay, let's do this one. Let's do x and z. Any ideas what I could do? Find x of n. Any ideas? Well, clearly as is, this is not an entry in the table. All right, let's do this. Bring 5 out. That's what Mr. Johnson says. Bring 5 out. Well, that we could bring 5 out, but that ain't gonna help. So bring 5 out. I guess that's what you mean. So how does that help, Mr. Johnson? It doesn't hurt though. Let's continue. So so what else we need to bring out? We need to bring Z out. Okay. Now this is beginning to look like something. If there was a Z here, then this is the entry in the table. But if you put a Z there, you got to put a Z here, so that becomes Z squared. So this is now 5 Z to the negative 2 Z over Z plus 0.2. Okay. So x of n then will be 5, okay, negative 0.2 to the power of n u of n. But this says delay by 2, n minus 2, n minus 2. And there you have it. Any questions about that? Okay. I will not give any written homework, but clearly, yeah, go ahead.
Now you're saying before we even get to the step, we should actually know what C transform we actually trying to make it look like, right?
Yes. Yes, you have to know you have to know that table. And you have to know that table not to pass the exam, not just to pass the exam. You have to know that table for the entire course. Any other questions or comments? Again, you have to practice this. So your assignment is look at the questions in chapter 6, and it says clearly find the inversity transform up. See how many of those you could do. Okay. So we'll leave it there for today. Have a great weekend.
Hey, Dr. Kedrick, can we get some more practice of this next class with you?
I don't know about that. I'm telling you what you have to do. You just have to go and do it. You have to make whatever you see. Well, we will do. We'll remember partial fraction expansion. Remember that?
Yeah.
We're going to do that next class. Because sometimes we see a quadratic. That's actually the sum of 2 linear terms. partial fraction expansion. So sometimes when you see a quadratic, it's not always a sine wave or cosine wave. So we can do more practice in inverse Laplace transforms, but I don't know how much more practice I'm going to be doing in just making making a function look like a table. That just requires you to practice and practice and practice. All right. Lord willing, I'll see you on Monday.
I'm on it.